And we will now go on with the agenda, and our next speaker is Wouter Carlet from imec, and he will talk about how to turn hyperspectral imaging into a quick and easy tool for domain experts. So Wouter, the stage is yours.
Thanks for the introduction, and thanks everyone for attending the talk. It's exciting to be back at Vision and to have the opportunity to talk to you about how we can apply on-chip spectral imaging for industry solutions. I'm program manager at imec's Hyperspectral Imaging on-chip program. So the technology that we developed at imec as being a CMOS R&D center starts from post-processing spectral filters on wafer level. So we have developed a technology that is capable of putting individual spectral filters on individual pixels of image sensors on the wafer. That results in a massive downscaling and integration of spectral imaging systems. So you can see on the left of the slide, you see the wafer, and after dicing and packaging, we turn an industrial machine vision sensor into a multispectral sensor, greatly reducing the complexity of making spectral imaging systems. And that results then in standard machine vision cameras suddenly having machine vision capabilities, suddenly having multispectral imaging capabilities. So at imec, we are developing this technology, bringing it to market, and bringing new USPs with the spectral imaging technology in that it's very robust. It is behaving really well in size-constrained applications because of its integration. So today, for instance, there's a lot of applications in space where for CubeSats, you save a lot of space by putting this sensor inside, but also patterning down to the pixel level provides new imaging modalities. And I want to zoom in there for a moment because it's very different from traditional imaging, hyperspectral imaging. And to make sure that you see or you understand how we do that, let's have a look at this CMV 4000 sensor, where we post-process an array of filters on top of it. So here, actually, what we will be doing in post-processing is putting a mosaic pattern, just like an RGB pattern with RGB filters, but then with multispectral filters. And that is then turning this panchromatic 4K sensor into a multispectral 16-channel video rate imager. So with that capability, and showing you some insights in what this looks like down to the microscopic level, this is what we do. This is what we're good at imec because of our history in transistor downscaling and having optical tools, CMOS qualified. We have this capability to do this kind of processing. It's a new imaging modality, which means that there's a lot of new application spaces that open with that. Having the video rate capability for spectral imaging means that suddenly you have a technology that's very robust against motion in your scene or motion in handling the device. For instance, thinking about medical applications where we think about surgical assisted surgery, where we have inherent motion in the body while we're doing the surgical operation, or in agriculture where leaves are moving during because of wind or the tractor movements. So there's a lot of new applications being made possible by this technology. But today I would also like to zoom in on what it means to bring a technology to market, because it's much more than just having a filter technology. It's actually making the filters, putting them on sensors, but it's also building an ecosystem. And that's what I like about Vision, that here we are meeting so many companies that are actively contributing and making these partnerships make that today we can go from filter to sensor all the way to a solution by having the right components developed. So today I'm going to stop talking about me and what imec is doing. I'll talk about our partners, because these are really instrumental to provide real solutions rapidly for real problems. So today, let's talk about how hyperspectral imaging on chip can be a quick and easy tool for domain experts. So first of all, it starts with a good camera. Having the sensor in a camera makes that the technology becomes accessible, that people can actually use it. And there we partner with companies like Zamia Photon Focus, where they focus today on making good camera. And in our partnership, we will be supplying from today onwards the spectral knowledge. So we help them in designing a good camera. We tackled problems of the past, roadblocks that we have experienced in bringing this camera to market. And we are providing our spectral insights through our software to the customers of these companies. And in that way, we are bootstrapping the application development at the industrial scale. To give you an idea of what it means as imec to bootstrap that, is that we will now provide a spectral validation service to these companies. So our partners that integrate our sensor in their cameras, they have access to a spectral validation service guaranteeing to the end user that this camera is capable of doing correct radiometric measurements reference to a calibrated target. So that when you start developing your application, you don't need to doubt whether this camera has the right lens and bandpass filter and configuration and so on. It's a certainty that you don't need to doubt the system, and that if you replace the system by a next system and you scale up, the system will behave exactly the same. Which is important, because if you develop your machine learning algorithm, you want to have the guarantee that the next and the next and the next is exactly the same. So every camera comes today with a spectral validation report, so you can be certain about that. The next thing that we provide to our partners and in the end to their customers that are the application builders is software that makes it easy to do spectral imaging acquisition. Because in the end, we have to be the spectral imaging experts and not our end customers. So we have made a software that with a few clicks and a few manipulations enables you to completely configure your acquisition and has the data processing pipeline to go from raw data to the data you need to do your application development. And what is more, we have also created the APIs that are required to have rapid access to the data from the camera and process that, so you can integrate that in a scalable in-field solution. Now, here's then the power of partnerships in industry. By providing these tools to industry, there's companies that start building their business on that. And for such a nice application as PerClass that made this software for hyperspectral imaging data analytics, not requiring you to be a data scientist. So their software allows to do quick annotations and find the right machine learning model for your application. And now integrating our APIs in that software means that there can be a direct end-to-end solution, for instance, in this demo, to measure sugar content in tomatoes. And with that development, by providing the building blocks, a good spectrally validated camera, the right software to do the data processing, and then also having the machine learning models directly interacting with the full chain, it makes that we can reduce the time to solution from months to less than a week. Of course, this is now a demonstrator, so more steps are required beyond that, but you see the tremendous progress that can be made by just having these building blocks. And the same we are also doing with LuxFlux, integrating the API for SnapScan and the snapshot cameras in their software. Then, beyond that, another problem with spectral imaging integration is light. So it's quite evident, or we take it for granted, that you need light to see. If you're in the dark, you don't see anything. But still, it's a big challenge in spectral imaging, because one of the most accessible light sources for spectral imaging today is halogen. It's cheap, it's directly available, and it's convenient to work with. Now, there's one problem with halogen, and you can see, well, it has the benefit of having a smooth spectrum, but it's inherently non-balanced. So if we look at the low illumination or low energy in the blue light, what does it mean for measuring objects in the blue, or features of objects in blue? So here's what happens. It doesn't work because there's no light. If there's no light, your measurement is false, and that's a big problem. If you want to capture features of the full spectral range, you need a better solution. So that is why we have engaged together with Effilux in building better lighting solutions. So by partnering with Effilux, evaluating their lamps, giving feedback from our lab measurements, and helping them build a better product, we can now together bring a better product to the market, enabling you not just to skip the step of figuring out what is your light solution. So yet again, it becomes easier to integrate spectral imaging in a system that will work. So what's the impact of this broadband light source, ranging from 400 to 900 nanometer, is that you can effectively measure all the features across the full spectral domain. So there's no doubt that this is the good solution for your application. So there's yet another problem solved, making it easier to go forward. And we're continuing that collaboration to provide even further spectral range lamps. Of course, Philux is providing them, but we are providing feedback to them to keep on improving. So that makes that today there's a full ecosystem emerging around spectral imaging technology, and by collaborating across the value chain, we can make it really easy and fast and provide a whole very accessible range of products and tools to bring spectral imaging to solutions. So today, there's a range of snapshot and scanning technologies available, having different interfacing technologies, USB 3 GiGi and also 10 GiGi with photon focus in US development, from vis to shortwave infrared, snapshot, video scanning, and compatible with many different applications, going from the field to industrial robotics or any other application that you might see fit. So with that, I would like to conclude with a call out to please engage with us, see which challenges you still have in this value chain in making solutions to market, and also ask us which solutions can the market provide, which partners do you need to be successful, because in the end, it takes collaboration to realize new things together. And our mission is to bring our hyperspectral on-chip technology to a commodity, to make it, to develop new frontiers with that, but we need to work together to get there. And I think there's a lot of work already done with the partners, so I look forward to discovering how we can develop new applications. For more information, please visit our website, contact us through our email address for more information. And of course, we're here on booth 8B11. Come talk to us. There's live demos. We're happy to explore. Pitch us your crazy idea, and we'll see how we can help you realizing it. So with that, I wish to thank you for your attention. I hope I could inspire you. And now if you have some questions, please, I'll be happy to answer.
The room is open for questions. So if there's still from the audience no question, we will go to the online chat. Can you extend, or is it planned to extend the approach to UV or sphere? So that means shorter or longer wavelength ranges?
Yes, so we can also apply our technology beyond the CMOS. And what we will be doing there, or what we are actually doing for instance, shortwave infrared imaging, is that we are patterning the filters on a different substrate.
Yeah.
So today we are patterning on glass, quartz, or borough float, and then it's a matter of a hybrid integration. So on shortwave infrared, we have an off-the-shelf offering where we are working together with SCD, or can work together with other camera manufacturers, and they are integrating then the filter on glass on the pixel array, resulting in then the first of its kind multispectral snapshots camera, or a snap and scan camera, point and scan camera. But we can also do the same for space projects on MCT, or for mining projects, or when needed for UV. So our core technology and core capability is the filter engineering, and we can transfer that easily to other wavelength ranges.
Okay, thank you. And concerning future developments, where do you see most of the work in future? Will it be about software to bring the data from the filter on chip sensors into application, or lies it in hardware development, because there are somehow unsolved issues in physics and so on? Or is it a trade-off? What do you mean?
I think that there's further developments in multiple dimensions possible. So for instance, on technology level, we have developed a filter that has a more Gaussian profile and a better overall performance in terms of out-of-band signal attenuation. So on technology side, there's still also innovation that we can do. But also then towards market exploration, we are seeing now that by bringing this technology to market for 7 years, now for snapshot technology, the academia has worked really intensively with our technology in the past 7 years, proving over and over and over again, for instance, that you can do non-contact blood oxygenation, blood volume measurements, and now it's only now, after 7 years, being adopted by industry. Same for the space technology. 5 years ago, they started developing CubeSats and what it requires to stabilize a CubeSat, investigating how do we need to process the data, to remove non-uniformities, do spectral calibration. And only now, 5 years later, now they are bringing that to scale. So it just takes a lot of development across the whole value chain, across on technology level, application research, academic research. We see trends are emerging, like for medical tech, for space, for advanced robotic vision, security and surveillance. Yeah, with these tools, I think this development can go very rapidly now.
Okay, okay. Thank you very much. Thank you.